All right, let's dive right into this explainer. August 19th. At first glance, it just looks like another standard day on the calendar. But if you look a little closer, it turns out to be one of the greatest and frankly most mysterious dates in all of mathematical history. We're going to treat this like a bit of a detective story today, tracking down exactly how the device you are using right now came to exist. And here's why.
On this one exact calendar date, across completely different centuries and in completely different countries, brilliant minds were either born or passed away. These people never met each other. They couldn't have even imagined the modern world. Yet, their ideas stacked perfectly on top of one another to build the technological reality that we live in today. So, let's meet them one by one and look at the clues they left behind.
First up, have you ever actually wondered how our modern machines cut metal, silicon, and glass with such unbelievable microscopic precision? Just think about your smartphone for a second. It's packed with billions of transistors, delicate glass layers, and this tiny metal housing. If the factory measurements are off by even a fraction of a hair, the whole thing shatters, or it just doesn't turn on. So how on earth do we manufacture at a scale smaller than the human eye can even see?
Well, the answer goes all the way back to August 19, 1584, with the birth of a French mathematician named Pierre Vernier. In a world that was, still building ships out of rough-hewn wood, Vernier was totally obsessed with the concept of exactness.
See, before Vernier came along, human eyesight could only measure so far. You could look at a ruler and kind of guess if a line was halfway between 2 millimeter marks, but it was really just a visual guess. He completely changed the game by inventing a tool with two sliding scales that were slightly offset from one another. This genius mathematical trick turned visual guessing into absolute certainty. It allowed humans to reliably measure the physical world down to the tiniest, most microscopic fraction. And this brilliantly illustrates how precision is literally the invisible ruler that builds our modern world. I mean, you absolutely do not get microchips without Vernier's obsession with exactness. Okay, still on August 19th, but we're fast-forwarding almost 80 years to 1662. The world is getting a bit more complicated, commerce is booming, and the problems we need to solve are moving from physical measurements into the realm of abstract numbers.
So think about your favorite weather app on your phone, or maybe a video game predicting a random lucky loot drop. How do computers actually calculate the exact probability of something that literally hasn't happened yet? Predicting the future feels like magic, but it requires a very specific set of mathematical rules to actually work.
And the secret to that predictive power, it lies with a man who passed away on this exact day in 1662, the legendary Blaise Pascal. Pascal was a true polymath. He dove into physics, theology, and most importantly for us today, pure mathematics. Get this, Pascal actually invented the world's first mechanical digital calculator, called the Pascaline, way back in 1642. And he did it just to help his dad, who was completely overwhelmed with the absolute nightmare of calculating 17th century French taxes by hand. But his genius didn't stop there. He later started exchanging letters with another mathematician about gambling and dice games, and in trying to figure out how to split the pot in an unfinished game, he accidentally birthed the entire mathematical foundation of probability.
So, the next time you pull up a forecast to check if it's going to rain, remember, you are looking at the math behind your apps, which was literally dreamed up by a brilliant mind analyzing 17th century dice games. Crazy, right?
Same date on the calendar, centuries later. We're transitioning from predicting the future to protecting the present. Let's make a massive leap right into the 20th century, arriving at the year 1939.
Have you ever wondered how our chat apps and banking portals keep our data completely encrypted? They use these massive, seemingly impossible mathematical locks. The encryption works because it asks math problems so insanely complex that a normal computer would take millions of years to guess the answer. But how do we structure those problems so they work perfectly every single time?
For the foundation of that digital armor, we look to the birth of British mathematician Alan Baker on August 19, 1939. He dedicated his life to a corner of mathematics that had frustrated humanity since ancient Greece.
Baker actually won the prestigious Fields Medal because he figured out how to systematically solve ancient, ultra-complex Diophantine equations. Think of these as algebraic puzzles where you're only allowed to use whole numbers as your answer, no fractions, absolutely no decimals. It's kind of like being asked to build a perfectly flush wall, but you're only allowed to use unbroken bricks. It is incredibly difficult, but by cracking how to solve them, he gave us the strict mathematical boundaries needed to process complex, secure algorithms.
Now, what's really interesting here is how finding finite, whole answers hidden deeply inside infinite possibilities gave modern computer science the ultimate framework. These are the tools and algorithms that literally protect your bank details and personal texts today.
But as computers became infinitely more powerful, a completely new problem emerged. We're staying on August 19, making our final leap in this detective story to the turn of the millennium, the year 2000.
Artificial intelligence, massive global weather simulations, heavy programming, they all require an absolute ocean of data. Have you ever wondered how our computers can handle endless, infinite streams of random numbers for these massive simulations without just losing their minds, running out of memory, and crashing completely?
Well, we find the answer with David Champernowne, who passed away on this exact day in 2000. He wasn't just any mathematician, he was a close friend and collaborator of the legendary Alan Turing. The father of modern computing. Champernowne worked right alongside Turing, and he deeply understood the challenges of machine logic.
He discovered how to construct what are known mathematically as normal numbers. Think of a normal number as a perfectly balanced infinite sequence. Like if you flip a coin, you expect 50-50 odds, right? A normal number guarantees that in an endless string of decimals, every single possible combination of digits has an exactly equal perfectly balanced probability of showing up. By forcing this strict mathematical order onto infinite decimals, he gave computers a totally reliable way to chew through endless data smoothly. So the crucial point here is that he found the perfect pattern inside the infinite chaos. He basically gave infinity a set of rules.
Take a step back and just look at this entire timeline. Vernier, giving us microscopic physical precision. Pascal, mapping out the mathematical odds of the future. Baker, locking down our digital privacy. And Champernowne, taming the infinite chaos of data. 4 foundational pillars of our modern world, all mysteriously tethered to this seemingly random date on the calendar. Every single person we met today looked at an unsolved, chaotic universe and asked this exact same question. What is the pattern hiding inside the chaos? And because they refused to stop asking, you are able to watch this very explainer on a pocket-sized supercomputer today. The invisible architecture of our everyday tech was built by people tirelessly looking for patterns in the noise. So what pattern will you find next?